Lesson 4.6, the determinant. Um, Later on, when we learn Cramer's rule, you're going to see what the determinant can be used for in order to solve a system of equations. But for right now, let's just make sure that we can actually calculate what the determinant is. Now, when we calculate the determinant, we'll take a matrix that looks like A. This is a 2 by 2 matrix. And then we can write det A, which means take the determinant. And then when we write it out in array form, we change the brackets so that we don't have the square brackets anymore. We just have two straight lines. And that tells us that we're basically, well, that we're looking for the determinant. Okay. For a 2 by 2 matrix, the determinant of a matrix A is going to be the product and the difference of its elements in a particular order. Let's go ahead and take a look at this. What we're going to do is we're going to do minus 2 times 3. So we're going to take a diagonal this way, minus 2 times 3. And then we're going to subtract that when we take the product of minus the square root of 5 times the minus the square root of 5. Okay, and let's take a look at that. That's minus 2 times 3 minus the square root of 5 times minus the square root of 5, which is just, 5 minus 6 minus 5, and it'll be minus 11. So the determinant of this is minus 11. We can also do an example here, a matrix that instead of having coefficients in it from a system of equations might actually have its own set of variables. Now, like I said, when we learn Cramer's rule, you're going to be dividing by this matrix. And so if this matrix happens to be equal to 0, that's going to indicate that there's some problems with the solution at those particular values. So in that case, when we would determine the determinant, we would also be paying attention to when this expression is equal to 0. So we're looking for zeros of an expression, of an algebraic expression. So if our array is minus y squared, minus 2, minus y, and 3, again, we're going to take the product of the diagonal elements coming down this way, minus y squared times 3, and then we're going to subtract from that. Remember, we're subtracting the elements that we're going to multiply going this direction. Okay, so minus 2. So minus a minus 2 times a minus y. A lot of minuses there. Keep track of those. This minus cancels with that minus, and we're still left with one minus. So minus 3y squared minus 2y. It's of larger matrices. For a 3 by 3 matrix, we can take any row as the set of elements that we're going to multiply by, and then we're going to multiply those by their cofactors. Now, a cofactor is minus 1 raised to a power. Now remember that power is even. It's just going to be minus 1 times minus 1 is going to be squared, and it's going to be 1. But if it's an odd power, it's going to end up as minus 1. So we're going to have this alternating sign in our cofactors. Plus 1, minus 1. All right, so what the cofactors will be that power of minus 1 times the determinant of a minor. Okay, so let's say if we're going to take the first product, which is 1, times the determinant of a matrix that has the elements 7, 2, 8, 9, and then we would take the element 2, and we're going to take from that, if we were to delete this first row in this middle column, we would be left with a matrix 4, 2, 2, 9. If we take that 2 times that minor, we call those the minor, times this factor, times this power minus 1, that's another thing we're going to sum. Okay, 6, the element 6, times its own minor, which is 4, 7, 2, 8, and that power of 1 will give us the elements, the factors, the terms that we need to sum. Okay, so the determinant is equal to the sum of the product of each element in a row and its cofactor. The cofactors are that power of minus 1 I told you about, and the determinant of its minor. Okay, so we'll run through all these very numerically here. Now, what about that power of -1 I told you about? All this does is it provides for an alternating sign to these terms. Okay, so if we take the indices, say this is the first element here, this is the 1, 1 element, so this is the first thing we're going to multiply here. 1, 1, so there's 1 and 1. We're going to sum those. We're going to sum those indices. That's going to be 2. So this is -1 squared just becomes 1. That's, it's a +1. But what about the 2, 1 element? The 2, 1 element has indices 2 and 1. So that comes to be 3. That sum is 3. -1 to the third power is -1. And we have a flip in the sign. What about 3, 1? Well, 3 plus 1 is 4. -1 to the fourth power, that's going to be +1. And again, this is now positive. Okay, so let's come on down and let's see what we can do with it. Okay, so the determinant, oops, that should be determinant. The determinant of W is equal to the first element times its cofactor, W11, plus the second element times its cofactor, W21, plus the third element, W31, little w31 times the cofactor of W31. Okay, so let's look at these elements here. The small, lowercase w, W11, W21, W31. So there are 2, 6, 1, 2, and 6. So there's 1, 2, and 6. And did I drop a minus on there? I did not. Oh, I see what I did. Yeah, at first I thought I made a mistake. But remember here, when we do this W21 here, we're going to pick up this negative sign there. Okay, so this 1 then is going to be 1 times the determinant of a matrix 7, 2, 8, 9. 7, 2, 8, 9. This 2 here is going to be 2 times the determinant of a matrix 4, 2, 2, 9. Remember, we're getting that matrix by omitting this row and this column. And again, there's this power of -1 that we pick up the negative sign. And then for the very last one, W31, we're going to get 6 times the determinant of a matrix with the elements 4, 7, 2, and 8. And we're going to use our 2 by 2 matrix formula. So 7 times 9 minus 2 times 8. 7 times 9 minus 2 times 8. We're going to evaluate the determinant here. This is going to be 4 times 9 minus 2 times 2. 4 times 9 minus 2 times 2. And then 4 times 8 minus 2 times 7. And we're going to continue evaluating everything inside those parentheses. We'll end up with 1 times 47 minus 2 times 32 plus 6 times 18. It turns out that the determinant of that matrix W is equal to 91. Okay, if you have any questions on how to do matrices, how to take determinants, be sure to ask, and I will do my best to answer. And you'll read on a little bit further into Cramer's rule, and you'll see why this is actually important. Okay? Have a good one.